So this IPsec site-to-site VPN, we have seen the theory portion. What I was telling is there are two tunnels, phase one and phase two tunnels. Phase one tunnel is nothing but negotiating key between R1 and R2 site. R1 is one site, R2 is another site. The middle one, the cloud, R3, is an internet, a public network, ISP. Using the reachability between the public IP address, ISP provides the reachability between 13, 13, 13, 1, 32, 32, 32, 2. ISP provides reachability. In the real world, we are able to ping the public side of our remote site. Using this reachability, we want to negotiate a tunnel. We would like to negotiate a tunnel. And what this tunnel should do, it should take our data from this source, any data going from this source, going to this destination. Let me call it as A and B for our easy, instead of saying 10.1.0.1, I'll say B. When traffic goes between A and B and B and A, vice versa, we want this traffic to go only through this tunnel. According to this traffic, the next hop is who? Router 2. According to the traffic going from B, the next stop is router 1. They don't see in between internet. Because the in between public network is invisible when you go through the tunnel, you can use your own private IP address and you can talk to this private, and the response will also come via the same tunnel. No NATing is needed. So we are not just expecting this tunnel with private to private communication. More than that, we want security. So we do not want anyone to negotiate the tunnel with us. We just want only the remote site to negotiate the tunnel with us. So bringing up the tunnel itself should be secret, which is done in phase one. Now I'm going to do phase one configuration. See what I do. I say crypto ISAKMP policy. Give any number. I say 10. What is that I'm going to provide in the policy? What is this ISAKMP policy and what am I going to define inside the policy? ISAKMP stands for Internet Security Association Key Management Protocol. Internet Security Association Key Management Protocol. I told you this VPN phase one tunnel is for key exchange. So the password that we are going to use to identify each other, we are going to hash it and exchange so that no one will know the password. And this password we change, password we don't change, but the hash value of the password we keep changing every 1 hour. We call it as rekeying. So that is what we are going to define. We are going to say that encrypt my password using, you can use any one of this algorithm. I'm going to say 3DES. What is the difference? DES is 56-bit key. 3DES is 3 times of 56. You multiply this by 3 times. Like it will come around 168 or something. And then AES is 128. Sorry, 256 AES. AES is 256. AES is more stronger encryption algorithm. See, you can choose any one, but whatever you choose this side, you should also choose the same thing on the other side. And for hashing my password, I can use SHA or MD5. SHA is more stronger than MD5, but I'm okay with MD5. For providing the integrity of this hash, I want to use Diffie-Hellman group, and I want to use Diffie-Hellman group algorithm 5, which will be this bit size. And for the authentication method, there are two methods. One is to use the certification authority, which is called as PKI, public key infrastructure. The other one is PSK, pre-shared key. This is public key infrastructure, PKI. I would like to use a pre-shared key now. Then that's all. We now need to give the password that we both will use, and the password should be same. For that, crypto, give any password. Spirit is my password. I need to use the same spirit as the password on router 2. Who is the remote peer with whom you are going to negotiate? 32.32.32. You should give the public IP address, reachable IP address. Don't give B's address. A and B are users of the tunnel. So don't mention users to construct tunnel. No. Tunnel should be constructed using the reachable public IP address of the ISPs. Okay, now what is next? That's all phase 1. Now let me put this in Notepad so that I can easily share with you. Do show history. This is what we call as phase 1 configuration. This is on 1. On R2.
So,
Yes, sir.
okay. So in phase 1, basically we decide for integration, encryption, authentication. There are some steps like confidentially. For those things, what we gonna use? Like
This password.
what?
This password is going to be encrypted, hashed, and provide an integrity with this algorithm, and it will be sent to this guy with 13.13.13.1 as the source. And R2 will also know that 13, 13, 13, 1 will come with me with this particular password's hash, because we are going to configure the same thing on router 2. The only difference in router 2 will be the address 13, 13, 13, 1. Yeah. So between these two, they're going to negotiate the phase 1 tunnel, nothing but they agree on phase 1, meaning they authenticate each other and they agree to form a secured phase 2 tunnel. That is what the end of phase 1 they decide. When both are when both are having the same algorithm for encryption, same hash, same defilement group for the pre-shared key, which is spirit, and when this matches, what matches? When the destination address of the neighbor matches, not only that, even the time, the clock they copy from this both the router, both sides the router should have same clock. When all this matches, we call it as phase 1 established. Means they have a very safe environment to negotiate phase 2. Phase 2 is the place where we define how the data that going between A and B to be secured. Similar to this phase 1, in phase 2 also we will have another combination of algorithms to encrypt data, not the key. Key is only phase 1. With the key, you know only the correct remote site. With the key, you identify the remote site. Boom. That's all. Once the neighbor is identified, you need to now send the data encrypted only with that neighbor. That is what we call it as phase 2 tunnel. That's what now I'm going to define. So let us write phase 2 policy. Phase 1 is over. Phase 2. Phase 2, as I said, it is to transform our data. The data that is going in between B to A and A to B, if it is sent without transformation, someone will easily find our data. So we want to transform it and send so that no one will be able to see our data. The transformed data should also be sent only to the phase 1 peer, the one which has successfully done phase 1 with you. Only with that person we want to send the transformed data. So this is completely safe. Not only your data is transformed, you will be able to send the data only to that site with which phase 1 is successful. Right, so let us write the combination algorithms that we want to use on both sides to transform our data. Okay, before that, I want to add something more to phase 1. You see, I have policy 10. I got only one remote site. On the other side also I'll have the same thing. What if I have 5 another sites? The other 4 sites administrators, they want different combination. The other guy wants here DES. The other guy wants here AES. The other guy wants here Shah. The other one wants here 2. What if they use different policies? Then you need to create all their policies with different number. Policy 10 for one neighbor, one peer. Policy 11 for another neighbor. Policy 12 for another neighbor. So when that neighbor tries to come and form VPN with you, it will first start with this lower number, try to match. See, you can even start one with 1, 1, 2, 3, 4. It'll always first, this is what the message that I want to share you now. When someone comes and negotiates, it first try to match with the lowest policy. If match is not found, next lowest, next lowest, next lowest, till the match found. So what I'm trying to say in short is you can have multiple policies with different policy number.
Jay, what do you mean by different neighbors? You mean different routers?
Yeah,
Mix up or
yeah, like router 1, you have, say I'm right now in router 2. My password is going to be expired after tomorrow. This is a site-to-site VPN. Means there should be only 2 routers for a VPN. So you may have multiple VPNs, that's the message. From router 2, if router 2 is a hub router, if router 2 is a hub router and you have many other spokes, and this guy uses different combination, this guy uses different combination, policy 1, phase 1. So for all of them, you can create different policies. You already have only one policy here, matching with this guy. So when you have different combinations, you can have different policies. When you have multiple policies, the policy with the lower number will be checked first. And let's say the lower value is matching with this guy. And when this guy negotiates, it will not match with this policy 10. It may match with policy 25. With that, phase 1 will be established. So router 2 will have 2 different tunnels now with different policies. Did I make it clear? Oh, I'm talking to you. Did I make it clear?
yeah, but in case that they use the same tunnel, I mean.
See, that's not possible. It will
Okay.
form, even if you have same combination, it will form separate tunnel only. How can it form same tunnel when the peer address is different? When the peer address is different, how can the tunnel be same? Isn't it? You're not answering. I'm talking to you. See, right now this is the peer address for tunnel between router 1 and router 2. If I have another router, will this be the address in the public?
No, there should be the different policy for the different tunnel, obviously.
Even if policy is same, this address is not going to be same.
Correct,
So
yeah.
it is going to be different tunnel.
Yes.
Co asks question, and when I answer, you are silent for this.
No, because I'm thinking because it's based on what you say. When you use in fact router 3, for example, and
No, router 3 is
router
already
3.
there. Router 3, don't use the word router 3, that's an ISP. Okay, router 4, take router 4. Tell me now.
Yeah, router 4. If we use router 4, we need to go to communicate, for example, with the host B. How we will do it?
Oh. What? You're like this, you will have another public IP address. You're going to negotiate tunnel from this IP address to that public IP address. Confirm tunnel. Okay, you do one thing. First, let us finish the side-to-side VPN with 2 route 6. If you understand how to do between router 1 and router 2, you can also do the same way between router 2 and router 3, router 2 and router 5. So let us continue. Phase 2 is like this. Crypto IPsec. So that's the command. IPsec. I was telling we need to transform our data. So the command is also transform set. So to transform, you have a set of algorithm. And the set of algorithm is identified with a word. You should give a word. Any word, I'll say for, or. And the combination. For encryption, I want to use maybe ESP AES. And for hashing, I may use AH SHA HMAC, means hash MAC. These are all algorithms. So if I use this combination algorithm, encryption and hashing, this combination, you must use the same combination on other router as well. So going to the notepad, phase 2, on R1 and R2 is same. This one. Phase 2 is over. Let me paste this on R1 as well. Now what is next is, which traffic should be transformed? A to B. If it is starting from router 1, it is A to B. If the VPN is coming from, if the traffic is coming from router 2 to router 1, then it is B to A, isn't it? So that we need to say by using access list. So what I'm going to do, I'm saying access list 101 permit I. If traffic is going from 10.1.0.0, 0.0.0.255, if this is the source, and going to B, which is 10.2.0.0.0.255. For this traffic only, I want to encrypt. Same way, I can put this in the notepad. I need to name this as interesting traffic. Which traffic you're interested to put in say the term interesting traffic? This one. And this is on R1 to R2. Likewise, R2 to R1, what is the interesting traffic? It's 2 here and it is 1 here. Isn't it? This is B's address, this is A's address. We are going from 2 to 1, which means B to A. So B comes first. Copy this. Put it on router 2. Done. Now focus very closely. This is the last move. Now I need to put this interface into this interface. All that I have configured so far in one interface. This is the outgoing interface. which is not.
Jay, did you configure auto one already?
Yes, sir. Here, sir. Please see.
Okay.
Now I need to put the access list. I need to put the ISA-KMP policy. I need to put the IPsec. All this thing on this physical port, which is not possible. So I'll use a map. I'll put it in that map. All this thing so that I can map it to the interface. We call that as crypto map. Crypto map. Give any number and then crypto map and say crypto map. Okay, give a name first, CMap, and then give a number, and then say I'm using IP, means phase 1, phase 2 term. It's IPsec, ISA-KMP, boom. And then peer, listen carefully, peer, who is the peer? Set peer. Who is the peer for R1? What is the address of peer? What is this taking too long? Are you understanding?
It's
Is the
32, 32, 32, 32.
Yeah. Now, next, set transform set. What is the transform set name I gave? Pour. Pour my spirit. Pour. Remember, I gave the name pour for the transform set. And then match. Which traffic need to use the tunnel?
Not
This
terrible.
traffic.
Yeah.
So we say match.
Jay, you are not very well.
What?
It's
So you see, first we need to define peer transform set, and then the traffic which will use this tunnel. You know, that's what we say match address 101. That's all. Now I need to do okay, set. Anything else left? Transform set is over. Peer is over. The other things are not needed. No need. Okay, that's it. So this same thing I have to repeat on the other side. So I'm going to do what? Show run section crypto. This is the one class crypto map. 3 things. I'll put this in the notepad. And the crypto map on R2. Everything will be same except that IP address will appear. The appearance of the peer in R2 will be 13, 13, 13, 1. Right, this is what I'm going to paste it on R2. Now I need to apply this to the interface. That's the reason why we created this crypto map. So the crypto map name is CMap. If I call the CMap under the interface, then it is done. You see, I go under interface G 3/0. This is where the VPN starts. I say crypto map CMap. Enter. Boom. That's it. You will see ISA-KMP. Yeah, ISA-KMP is on. Phase 1 is on. The negotiation is on. We have to apply this on the other side. interface G3/0 crypto map C map. Boom. Now we have done. Let us check now first whether the phase 1 negotiation is happening. Show crypto ISAKMP SA. This is the command. I don't see anything. Let us generate some traffic and see. Ping 10.2.0.1 with a source 10.1.0.1. All right, we don't have route to reach 10.2.0.1. That's why it didn't even kickstart. See, it's not even kickstart. We need to simply say if any traffic wants to go to IP route, we need to try to push the traffic via G3/0 so that the crypto map will take over. We need to say any traffic going to 10.2.0.0, 255.255.255.0. Send the traffic via G or send the traffic to 13.13.13.3. Just we are trying to push it towards R3. R3 really don't know anything about 10.2. R3 don't know anything about A and B. We're just trying to push the traffic via this interface out so that all the tunnel informations will be kicked off, not kicked off, kicked up, and it will use the tunnel. And the tunnel gets established. So let me also go and write a static route here. IP route. If any traffic is going to 10.1.0.0, 255.255.255.0, send it to 32.32.32.32.3. After you say this, you go and try now to ping, your VPN will come up. Yeah, it's pinging, which means VPN is up. Let us go to router 3 and see. Router 3 don't have any idea about these networks. There is no idea about 10.1 or 10.2. But you are able to ping from router 1 to router 2. This proves that your tunnel is up. Let us go and verify whether the encryption happens. Show crypto ISAKMP SA. Here it says yes, VPN is active between this is the destination and this is the source. And if you go to router 2 and check the same command, show crypto ISAKMP SA. This is phase 1 we are testing. Yes, phase 1 is good. Let us check phase 2. Show crypto. Phase 2 is the one via which the data has gone. How many times you ping? 2 times. How many packets? 10 packets. Let's see how many packets got encrypted and decrypted so far. Show crypto IPsec SA. This is phase 2. Look, you can see 9 packets got encrypted and decrypted so far. Yes, when you checked, when you pinged the first time, you lost the first packet. You see? So we lost the first packet. Out of 5, only 4 was successful. And after that, when you ping, it was all 5 successful. So 5 plus 4 is 9. That's why you can see here, 9 packets were encrypted and decrypted. You can also check it on R1. Show crypto IPsec SA. You can see here also 9. Let's do one thing. Let us ping 100 times. Now I need to see 109 packets encrypted and decrypted. Let's check. Look at this, 109 packets encrypted and decrypted on both. I should see on both sides. Yes, it is. All right. So this is the end of this